Hello, kids. Welcome. Welcome to the Mr. Krause Hour. An hour of mathematics, an hour of fantasy, an hour of just complete and utter frustration and fun. I'm glad you decided to join me. I'm glad you decided to be a part of the mathematical world of beautifulness. Just welcome. Welcome. Thank you for coming. I appreciate it. Let's get started. Day one. Oh my God, day one. Who gets more excited about math than me? Probably Mrs. Newman. I don't know if you know Nooms, but she gets probably a little bit more excited than I do. Let's see if the pen works. Pen, Mr. Key, looks like it's working. Oh my gosh, my computer's not dying on me yet, but that'll happen soon. All right, so here's a little bit of review, a little bit more review than we've done in the past. To simplify, let me draw this a little bit bigger for you. Maybe I can make this a little bit bigger. Oh yeah, pen's slowing down already. Bang, bang. Oh my God, that's way too big. That's way too small. Oh, yeah, there we go. It's already acting up. All right, so draw, erase. Okay, now let's see if we can go back. So I can just do it here then. This 2 goes into itself once. This 2 goes into 4 twice. Who's got more x's? The denominator, so you subtract them. So this one cancels with one of these. So it leaves you 1 over 2x. That's it, kids. On this one right here, what we're going to have to do is you can't just start canceling stuff out. You can't cancel this x out with this x out and do stupid stuff like that. Don't do that. Math just makes your math teacher mad and a little bit cuckoo. Cuckoo for Cocoa Puffs. So what we're going to do is factor. We're going to take out an x out of the numerator, and you're left with 3x plus 1. Be careful. And out of the denominator, we're going to take out and do nothing. We're just going to rewrite it as 5x. Now I can start canceling. This x cancels with this x, and actually that's it. So you're left with 3x plus 1 all over 5. And you can't do anything after that. Some kids can actually do this right quickly in their head. What some kids will do, and it's sort of rather embarrassing, they'll be like, all right, Mr. Krause, well, this x cancels with one of these x's, and this 4 goes in this 4 times, and they'll get x minus 4. And I'll tell them, no, that's not quite right. It's actually x plus 4 is the answer. Well, it was really close. I was only off by a little bit there. You know what I'm saying? I'm just only off by a little bit. Oh, no. You were off by a lot. No soup for you! All right, it's a little Seinfeld. Anybody know Seinfeld? That's a little Seinfeld reference. So anyway, in order to do this, you have to, every time you see adding and subtracting, I put like wedding rings around them, like a married couple. You can't break them up unless you factor them. All right, so what we're going to do is we're going to factor them up. So x, there's an x supposed to be there, x plus 4, x minus 4. And the denominator is x minus 4. So now that I've factored it, now I can see, oh, they do have a common factor. The common factor is x minus 4. Divide that common factor out, and you're just left with x plus 4 over 1, but we don't need to put it over 1. There it is. All right. By the way, you should not just be watching the monkey perform. You should be trying these on your own. Monkey's tired of performing. Let's factor the numerator out. We can take a 25 out, and I'm left with x minus 5. Oh, now that you smart kids are seeing it. X plus 5. X minus 5 in the denominator. The minus 5s cancel, and I'm left with 25 over x plus 5. Moving on. Moving on up to the top. We finally got it. I'm telling you, kids, I missed my calling. I should have been a singer. By the way, Coffee Pot's not really working right now, and I didn't have time to run to Brugger's to get my Brugger's coffee, but I'm going to get my Brugger's coffee a little bit later when I take my daughter to church. But can't do that right now. So, pen's not working great, so I don't know if you noticed. Donations would be awesome. X plus 1, x minus 1. All right, so I factor the numerator. The denominator, another trinomial. We can factor it. X and X, because this is a plus, they both have to be the same sign. And because this is a plus, they both have to be plus. Plus 2, plus 1. Take out the black pen. And cancel those puppies up. And I'm left with X minus 1 over X plus 2. All right, last one over here. Let me slide over so my big bald head gets out of the way. In the numerator, I can take out a 2x. Not just an x, not just a 2, but a 2x. And I'm left with x minus 6. In the denominator, I have just x minus 6. Those cancel, and the answer is 2x. Then we get into a little bit more fun. It's mathematics. Fun is one of the F words you're allowed to use. In the numerator, I can take out a 3x, and I'm left with, ooh, wait a second. Let's back up the crazy train, homie. Oh, what happened? In the numerator, I can take out a x squared. These two things only have an x squared in common. And then I'm going to look at these two. So then I'm left with 3x minus 1. Oh, I forgot I changed this problem. Make this a plus. I don't know what I was thinking about. I'm going to have to change that back. Make that a plus. Minus, and out of these two, the only thing I can take out is a 1, but I'm really taking out a negative 1. So I'm left with 3x plus, well, this should be plus now, plus 1, because I changed that to a plus. All right, so continuing on with the numerator, well, it's all over x plus 3. Oh, and I changed that to an x plus 1. Ah, my God, this is so annoying. All right, so it's x plus 1. This is x plus 1. That should have been x plus 1. So this problem, oh, man, whatever, Holmes. All right, so if you tried this one on your own and you just came to watch me do it, I'm sorry. Forgive me. The numerator is 3x plus 1. They have this as a common factor. And then I'm left with x squared minus 1 all over x plus 1. Yes, for those of you who just saw that. I'm sorry. Well, remember, this is x plus 1, x minus 1. These cancel. And I'm left with 3x plus 1 all times x minus 1. And my big head is probably right there in the way. Sorry about that. Put some hair on me. Let's see if I can get some hair on me. We'll see if I can get some hair on me. Maybe I'll slow down. Move it down. Maybe that put hair on me? No. That put hair on me? Maybe. Slide down a little bit. Maybe it's down here. At some point, you freeze frame. I got hair on me. Oh, yeah. Mr. Krause looking sharp with the dew. I don't know where I'm going. View. Page width. Okay. So let's talk about rationalizing the denominator. And this comes in when we're looking at square roots and, oh yes, you may not leave a radical square root. I'll put it in words. I'll put this in parentheses because people keep thinking that I don't know what I'm saying. I haven't even woken up yet. I need coffee, man. My coffee machine's just like not working properly. It's so upsetting. Now that I'm over that. You may not leave a radical, a square root, or an I, which stands for imaginary numbers, in the denominator of a fraction. You also shouldn't leave negatives in the denominator of a fraction either. So I will be picky about that as well, because that is not good. I just like saying that. That is awesome. So we're going to look at this first one here. The problem with this first one is we have a radical in the denominator. So let's take a little trip. Someone tell me what 5 times 1 is. You right there. No, that guy. The guy behind you. Oh, yeah, you. Oh, that's 5. Oh. Someone tell me what 3/4 times 1 is. Same guy. No, the girl next to you. Yeah, you. Yeah, perfect. Oh, yeah, right. 3/4. Perfect. Nice job. And then someone tell me what 2.783951172 is. Times 1 is equal to. I'm not writing it out. It's that thing. You get my point? If you multiply by 1, you do not change the value of whatever it is. It's the one single number in the entire world that if you multiply by it, it doesn't change the value. So exciting! Oh my God! I learned something so cool in math today. You can multiply by 1 and not change the... You guys should run and tell your parents, Mom, if you multiply by 1, it doesn't change the value. I know. Don't hit the stop button. It's not that exciting. So that's what we're going to do. We're going to multiply by this by 1. So I'm going to multiply by 1, and I get 5 over the square root of 3. And the cool thing about multiplying by that 1 there is I got rid of the... Oh, crap. I didn't get rid of the radical in the denominator. I have to get rid of the radical in the denominator. And I know I'm supposed to multiply by 1 because multiplying by 1 doesn't change the value. So I don't want to change the value, and I have to multiply by 1, but I just multiplied by 1, and it's still 5 over the square root of 3. I don't get it. What the... Oh, hold on a second. Wait a second. Let me think about something for a second. Hold on. This is going to be interesting. What is 5 divided by 5? Equal to 1. What is negative 2x divided by negative 2x equal to 1? What is 7.123 divided by 7.124? Not 1. Okay, 3. 1. God, that was fun. I tricked you. You were about to say 1 and I tricked you. What is a flaming pile of dung over a flaming pile of dung equal to? And those are supposed to be the exact same flaming piles of dung. Oh, if you have a flaming pile of dung over a flaming pile of dung and they're exactly the same size, it's equal to 1. If you have a identical twin over an identical twin, even though one of them clearly has a much bigger head, you get 1. Well, who cares? It's important that you understand that 1, this is a kind of an SAT thing too for those of you still listening to me and not like I just gone off the deep end. It's kind of an SAT thing. Multiplying by 1 doesn't change the value, and you can represent 1 any way you want to. So in this problem here, we're going to represent 1 in a very fancy way. We're going to represent 1 by the square root of 3 over the square root of 3. Now, I'm going to take you through this slowly, and then we're really going to ramp things up. The numerator is just 5 square roots of 3. But these two multiplied together give me square root of 9. And some of you might think, well, you still have a radical in the denominator. No, I don't. You're not very smart, or you're not thinking clearly. I'll have this other guy go, you can simplify this by just doing that, goes in there, and you get radical 3 in the denominator. No, that's what you started with, fool. So, what is the square root of 9? The square root of 9 is 3. And therefore, we have change the problem. We do not have a radical in the denominator, and we're finished. That's it. That's the answer. That's all it is. What? All that craziness for that? Yep. So in this one right here, we're going to multiply by square root of x over the square root of x. Oh yeah, it gets that easy. So in the numerator, you have 2 square roots of x. Now, I can multiply these together and get the square root of x squared, but that's just going to turn out to be x. Skip this step. The reason we multiply radical 3 times radical 3 and get 3, or radical x and times radical x and get x, or radical 2xy squared times radical 2xy squared is equal to 2xy squared. as long as you're multiplying it by the same thing, you're really squaring it. And if you square the denominator, you square that radical, you square that, you square that, you end up with just this. Now, you can't square the original fraction because that actually changes its value. You have to multiply by 1, which is what the same number over the same number. All right, so let's take a look at number 10. Number 10 has the imaginary number I in the denominator. So what we're going to do is multiply by 1 in a very fancy way. We're going to multiply by I over I. By the way, get in the habit of writing your I's like this or something like that. If you just write like this, you know, and you go, oh, the grader's going to think that's a 1, right? And remember, I don't grade anything. I can't even look at your tests. Can't see them at the end of the year. So you're going to be relying on whatever the grader is. And at the end of the day, our eyes are going like, that's how we talk too, by the way, at the end of the day. Actually, some of us talk like that all the time. But, yeah, so you want to make sure you make our graders' life easy. The numerator here, when you multiply by I over I, is 7I. Pretty exciting. The denominator is I squared. And someone in the audience is going, well, you guys still got an I in the denominator of the fraction, Mr. Krause. Yeah, you're not very smart. You have forgotten a classic thing that you've been taught. And that is that I squared is really -1. Oh, yeah. Do you remember the I circle? A little trip back memory lane. I to the 1, I squared, I cubed, I to the 4th. If you remember correctly, I to the 1 is just I. That's really not very exciting. I squared is -1. And if you go to the opposite side of the circle, it's just the negation of the opposite side of the circle. So instead of being I, it's -I. Instead of being -1, it is +1. But the thing I want you to remember, and this is key, is I squared is really -1. And I think I said earlier, you never leave the negative in the denominator of a fraction, so we should bring that up. So my real answer is -7I. All right. Over here, I'm going to take you through this problem twice. We're going to multiply by, I know what you're thinking, we're going to have to multiply by 3I over 3I. So let's do that very quickly. That's fine. That's still 1. In the numerator, you get 3I times x. I always put the variable last. And then these two multiplied give me 9I squared, which is really -9. So if I simplify this, 3 goes into -9, -3 times. We'll put the 3 there. And since we can't leave negatives in the denominator, we'll just put it up top. So I really end up with -ix over 3. Now, the reason I said I'm going to do this 2 times is because I want you to go back and take a look at the original problem. The original problem, the only issue that I have here is the I. The 3 is not a problem. So I don't really need to multiply by that 3. I really just need to multiply by I over I. Now, remember what our answer was over here. If you want to rewind, you can, because I know I did pretty quickly. It was -xi over 3. Well, if I multiply by I over I here, I get xi, I'm just going to keep it like that for now, over 3I squared. And, of course, I'm going to get the kid that actually cancels the i's here. And we're like, dude, you just went back to the original. Don't do that. And this is -1. So this negative goes to the top. Remember, it's just a sign. So you get -I times x over 3, which is the same as this. All right, kids. Wow, more exciting. Take a second for me, please, and double distribute these out. Let me get to a different color. X plus 1. X minus 1. If you want to hit pause. I'm waiting. Okay, I just paused enough. So you should have at least hit pause by then, and now we're back live and ready to roll. Let's double distribute. You get x squared minus x plus x minus 1. Well, don't these two just cancel each other out? And you end up with x squared minus 1. And if I double distribute, well, let me tell you why I'm doing it. Let me not tell you why I'm doing it. Let me come down here. Here's the problem. First of all, I'm going to change this and make this negative up here. But here's the problem. Most kids, when they're not paying attention in class and they're sleeping, they're going to go, oh, wait, the radical 3 is the problem. So let's multiply by radical 3 over radical 3. And in the numerator, you get negative 7 radical 3. And in the denominator, because this is a binomial, you have to distribute. So I'm going to distribute to both of these. And I get 5 radical 3 plus 3. Now, the reason it's 3 is because when these two multiply together, they get positive 3. Well, did that fix my problem? I still have a radical in the denominator, and you're not allowed to have a radical in the denominator. So this was a bad idea to begin with, and that's why I want you to think about what we're doing up here. What if I were to take x plus y times x minus y? And I did this, I would get x squared minus xy plus xy minus y squared. Well, once again, these cancel. So why am I telling you this? Well, we're about to get into it, but I want you to understand that these two things here, because they differ by a sign, are called conjugates. Conjugates. X plus y, x minus y are conjugates. The exact same set of parentheses, one's plus, one's minus. Let's see how that's going to help us out here. Again, I don't like that negative in the denominator, so I'm just going to move it up to the top. So here's my binomial that's a problem. And we already said we can multiply by 1 any way I want. I can have a flaming pie. Oh, I can have a big pepperoni pizza on top and a big... Starting to get hungry. Getting some Brugger's bagels this morning. Oh, yeah. Maybe I'll show you the bag later. Get you all jealous. So we're going to multiply by 1 any way we want. And what we're going to multiply by is the conjugate of this. The exact same thing, except with a minus. But if I put this on the denominator, I also have to put it on the numerator. And we're going to multiply these out. Now, in the numerator, I want you not to distribute. I just want you to write it as 7 times 5 minus radical 3. And I'm cool with that. It's less work anyway. Just copy it down. We're multiplying. Oh, I'm off the screen. I'm back. By the way, how you like the bald head? Looking pretty sharp today. Got a little fresh dew cut for you. Now we're going to double distribute. So these multiplied together give me 25. And then minus 5 radical 3 plus 5 radical 3. And then negative radical 3 and positive radical 3, when they multiply, give me negative 3. Now, I could write negative square root of 9, but it's really just negative 3. Well, why did I do this? Why did I do this? I hope it's obvious now. These two things right here, let me just put them in yellow. These two things, that's negative 5 radical 3 and positive 5 radical 3, they cancel. So if I really get rid of those things, do you see a radical in the denominator anymore? You do not. So in the numerator, it's 7 times 5 minus radical 3. And in the denominator, it's just 25 minus 3, which is 22. And there's your answer. Remember, we don't solving anything. We're just simplifying an expression because there's no equal sign. We're just simplifying. So what we're going to do is, in this case, we're going to multiply by the conjugate of the denominator, which is the square root of x minus 3, the square root of x minus 3. Now, Because I know these are negative radical 3 and this is positive radical 3, I no longer have to do that. I know they're going to cancel. It would be the same thing if I told you to double distribute this, x plus 5, x minus 5. By now you should say, hey, that's just x squared minus 25, because it's the difference of perfect squares. You should recognize that you don't need to do the middles, the negative 5x and the positive 5x. They're going to cancel anyway. So in the numerator, we're not distributing 4 radical x minus 3. And the denominator, we're going to do, I'll do this in a different color. We're going to do square root of x times the square root of x, which is just x, minus, it's always minus because they're conjugates, and one has to be plus and one has to be minus, positive 3 times negative 3, which is 9. There's your answer. Same thing with imaginaries, except it's a little bit trickier. Not much, a little bit trickier. We're going to multiply by the conjugate. 8 minus I. 8 minus I. So there is one small tricky part of this. So we're going to multiply. In the numerator, we're not distributing. We're just going to write it as 2, 8 minus I, all over, there's 64 minus, what is positive I times negative I? That's I squared. But if you remember correctly, I squared is really negative 1. So what I really have here is minus negative 1. Well, that's really just a plus 1. So my denominator is a 65, and my numerator is just 2 times 8 minus I. Don't forget, this piece right here is key. And many of you are going to forget that it's a minus, then it's an I squared. Just be careful of it. Be careful. Don't do anything stupid. Estupido. I didn't call you stupid. Put this in parentheses. Oh, yeah, I did call you stupid. Well, yeah, not you, that other guy. Oh, yeah, you know what I'm talking about. All right, we're going to multiply by the conjugate, which is 1 plus 2i. The conjugate is the exact same set of parentheses, just a different sign. In the numerator, we're not distributing. 6, 1 plus 2i, all over. All right, multiply these together, I get 1. It's always minus, and then it's 4i squared. But remember, this is minus, and again, multiplying by I squared just changes the sign, because this is negative 1 right here. So this really becomes minus negative 4. Well, minus negative 4 is really plus 4. So my numerator is 6, 1, 1, 1 plus 2i, I, all over 5. I think I'm going to take another trip just for fun. So now it's more time for you to practice. So I'm going to go through these and do these and talk you through these. But, you know, you might want to hit the pause button every time, because now we're just going to practice for the next 2 pages on some of these. So if you want to, fly through them, try them on your own. If not, you can just watch the monkey perform. In the numerator, it's x. Signs are going to be the same. They're both going to be minus. Multiply to 9 or 14, add up to 9 is 2 and 7. Denominator, signs are going to be different. One's going to be plus, one's going to be minus. Multiply to 14, add up to negative 5, that's negative 7. And positive 2. These cancel. There's your answer. The numerator here, nothing to do, but the denominator I can take out a GCF. So in the numerator is just 4x squared. In the denominator, I'm going to take out a 4x. And I'm left with 5x minus 3. So now I got to simplify. The 4's cancel. This 1x cancels with one of these. So I'm left with x over 5x minus 3. In the numerator, it factors to x plus 6. Remember, difference of perfect squares? What are these things right here called? What are they called? What? Conjugates, because they're the same exact binomial with a different sign. And the denominator is a perfect square trinomial, otherwise known as x plus 6 times x plus 6. Or if you were really smart, you could have just written x plus 6 squared, but that's okay. Those cancel. There's your answer. Moving on down. Oh yeah, we're flying. If I'm going too fast for you, so what? Hit the pause button. 18, I'm looking for 19. Okay, now we're going to rationalizing. I'm going to multiply by radical x over radical x. This one gives me 5 radical x over x. Done. Next. Uh-oh, got a radical 2. Not allowed to leave it in the denominator. So we're going to, oh yeah, it doesn't matter if we have, so radical 2 plus 4. The conjugate. Radical 2 plus 4. The conjugate. And I'm left with 5 times radical 2 plus 4 all over. These two multiplied give me 2. 2. These two multiplied give me negative 16. Well, this is really negative 14. You're not allowed to leave the negative in the denominator, so I'm just going to put it up top. Negative 5 square roots of 2 plus 4 over 14. Some calculators actually crash if you leave a negative in the denominator. All right, moving down. All right, we're going to multiply by the conjugate of this. And the conjugate of this is the square root of x minus 6. The square root of x minus 6. In the numerator, not distributing, 3 square root of x minus 6 all over. These multiplied give me x. These multiplied give me minus 36. That's done. Bodied. All the cool kids say that. What is the conjugate of that? What is the conjugate of this? Remember, conjugates are the exact same thing with a different sign in the middle. So the conjugate of this would be negative radical x minus 4. Don't get tricked by that minus there. It's just the opposite sign in the middle. Moving on down. Let's get to some imaginaries. Oh, what's the conjugate of this? Again, it's the exact same thing, but with a plus sign in the middle. Don't get fooled. What is the conjugate of a plus bi? This actually, I think, was a test question one, right? A minus bi. Pretty sneaky. All right. So I think these next ones are going to be a little bit more creative and interesting. In this one right here, remember, it's the denominator that's the issue, not the numerator. And the only issue I will highlight in yellow pen is that thing right there, that I. So because that's the only issue, I'm going to multiply only by I times I. Now, this case you are going to have to distribute. I you're going to want to distribute. So, because otherwise you got issues. So in the numerator, I'm going to multiply I times x, and I get ix. And then I times 3i is plus 3i squared. In the denominator, I'm slowly going to do it. It's 5i squared. So this is really negative 1. So what I have here is ix minus 3 all over negative 5. Now, why is it negative 5? Because this is really a negative 1 here. You're not allowed to leave that negative in the denominator, and you have to be very careful. If you take it and put it in the numerator, you're going to have to make sure you put this in parentheses. So you can either do this, or if to be safe, just put the negative out front and do ix minus 3 over 5. Tough problem. That was tricky. Okay, again, the I is the problem here. We're going to multiply by I over I. I hope I get this right. I have my eye on you. Oh my God, it's getting crazy. Multiply by I times I. Oh my gosh. Look, I almost made a perfect right angle. It's gorgeous. Let's distribute. So we get 3i minus I squared all over 2I squared. I don't know why I keep saying I. So in the numerator, this is really a negative 1 here. So it's minus negative 1. So it's really 3i plus 1 all over negative 2. So we don't like that negative down there. So let's get rid of it. So we get negative 3i plus 1. That's an I. All over 2. I think I got a couple left. I think I got one really tricky one right here. Okay, so we're going to multiply by the conjugate. Don't start thinking, oh, everything's going to cancel when you do this stuff, just cancels. Remember, we're multiplying by 2 plus the square root of x, the conjugate of this. 2 plus the square root of x. Well, in the numerator, we're going to get 2 plus the square root of x squared all over 4 minus x. Done. That easy. It looks so complicated at first. All right, this one we're going to multiply by radical x plus, not plus, got to use the conjugate. What happened to my eraser? It's sort of annoying. Minus x all over radical x minus x. I'm not going to distribute for now. Radical x minus x. All over. These multiplied give me x minus x squared. And I believe that's it. I don't think you can do anything else. I mean, I can distribute. I would get x minus x radical x all over x minus x squared. Or I can factor out of the denominator, take out an x, I'm left with 1 minus x, but nothing's going to simplify. So this is good enough. I think that's it. I think we're done. No, yes, we are finished. Oh my God, day 1 is over. So exciting. Hit subscribe, hit the like button, please. If you got a spare nickel, or, you know, if the ads are exciting, you can hit them. All right, guys. Hope you had a good time. Hope it wasn't too long. Catch you on the flip side. Bye.